Hello dear people, welcome back. This question is for 4 marks and is from GATE 2008 exam. It has two parts. Let us solve them one by one. So part 1 is for 2 marks. I am going to discuss whatever information is given in the question. Then we'll move on to part 1 of this question. They are saying we have this host X with this IP address and there is a host Y with this IP address. Okay, both of these machines, they are connected to each other via router R1 and R2. R1 has these two IP addresses. Okay, this router has two IP addresses. They are written here. Similarly, this router also has these two IP addresses. And the network mask for this network is this one. Subnet mask is 255.255.255.224. Okay. So this is all the information that is given in the question. Now I am going to read part 1. Part 1 says, given the information above, how many distinct subnets are guaranteed to already exist in the network? Okay. So we need to find how many subnets are surely there. First thing is, do routers get IP address? Yes, routers will have a IP address and generally routers get more than one IP address. See, if this is a router and suppose it has these 4 interfaces, okay, each interface will get one IP address and suppose this network is connected to this router on this interface. So whatever IP address this interface is going to get will be a part of this network. Okay. Similarly, if this interface is connected to this network, the IP address that this interface will get some IP address. It will be from this network. Okay. Parallelly here also and here also. And if some interface is not connected, it will not get IP address. Okay. Now let us start this question. So the given subnet mask is 255.255.255.224. That means 3 octets are all ones along with first 3 bits of the last octet. Okay. So yeah, here I've converted this subnet mask into binary. It will be all ones till here. First 3 octets along with 3 bits from the 4th octet. They will be all ones. Okay. All ones means network ID. And last 5 bits are for host ID. Okay. That means in this network, for all IP addresses, these many bits, they are 8 3s are 24, 25, 26, 27. First 27 bits represent the network ID. Okay. Let's do one thing. Let's find out the network ID for this IP address. IP address of X. Okay. So first 3 octets will be copied as it is. And first 3 bits of last octet, they are 0, 1, 1. Okay. So there is a subnet that ends with 0, 1, 1. I'm writing it here. This is not the subnet ID. Okay. I'm saying first 3 octets, they are as it is. I'm just analyzing the last 3 bits of network ID or subnet ID. Just these 3 bits. So X belongs to some subnet whose last 3 bits are 0, 1, 1. Okay. Parallelly, let's analyze both of them. So 135 is this number. Okay. If you convert it into binary 8 bits, you are going to get 1 000 0 0 1 1. Okay. First 3 bits of this last octet are 100. Okay. First 3 bits of this IP address, the last octet, they are 011. So we have already seen there is some network whose subnet ID ends with 011. Okay, it's already counted. Now let's analyze this one. It is 1000. It is done. Sorry, 100. Okay, it is also done. And 67 is 010. Let's write this one 010. Then we have 80 in last octet. 80 means 010. Yeah, this one is also done. So both of these belong to this one and this one. They belong to 100. This one and this one, they belong to 011. Okay. See, let me just write the complete network ID. So for all of these bits, copy this pattern as it is. Okay, it is 192.168.1.011. So all of the ones, wherever we have all of the ones, I'm copying those bits as it is. 192.168.1. 3 bits are 0111. Okay. Here also they are 0111. So for both of them, this is the network ID. And we have to place zeros in host ID. Okay, so I'm placing zeros. Here also zeros. And 192.168.1. 192.168.1. Okay, see, 192.168.1 is common for all of them. Okay, so even if you are analyzing this one, that means if you want first 27 bits as it is, 192.168.1 will be there. Okay, and these 3 bits are 100. So 100, and in host ID I've written all zeros. Okay, so you can see surely these 3 subnets exist. Okay, they were asking how many distinct subnets exist. We can surely say that these 3 subnets are there because these IP addresses are such that some of them belong to this one, some of them belong to this one, and some of them belong to this one. So we can say answer to the first question is 3. Let me just read the statement once again. First question was, how many distinct subnets are guaranteed to already exist? These 3 are already existing because we have IP addresses that belong to these networks. Okay. Answer to the first question is 3. Now I'm going to read the second question. So its statement is, which IP address should X configure its gateway as? Okay. So now we want to find what will be the IP address that is saved as gateway of X. What is gateway or default gateway? Gateway means whenever X wants to do some indirect delivery. See, if this is some network, there is X and destination D. If destination is in the same network, we call such a delivery as direct delivery. So X will directly send the message to the destination. But if this D is in some other network, then X cannot directly contact D. X will first contact default gateway. Okay, mostly it is a router. So if I want to send a message to some destination which is not in my network, I'll just simply forward that message to default gateway, and rest all of the things default gateway will take care of. Okay. If this machine wants to send a message outside its network, that means to Y, then this machine is going to send that message to some router, which is obviously R1 because it is connected to R1. But what will be the IP address to which it will be sending? That will be the address of this interface. Okay, so we need to find, is this address that belongs to this interface or this address belongs to this interface? Now already I have told you that this interface is going to get address from this network, which means X already has a address from this network only. This interface will also have a address from that network. This means network ID of this IP address and this IP address must be same. Okay. Now have a look. Network ID of this IP address is 011. Okay. This entire is the network ID, but these 3 bits are 011. And for this IP address also these 3 bits are 011. That means this 192.168.1.110, this address must belong to this interface, and this address will belong to this interface. Okay, because see, this IP address can never belong to this interface because this IP address is simply not a part of this network. Okay, this interface will get a IP address from this network only. Okay, that means this IP address's network ID and this IP address's network ID has to be same because both of them belong to a same network. So default gateway for X will be 192.168.1.110. Okay, this is the answer to the second question. See, how can I say that both of them have to belong to same network? For example, this is X, okay. Say this is node X and X wants to send a message out of its network, okay. So it will send a message to the default gateway or router. Now router has to be in its network at least. If this router, this is only not in its network, then X can't send a message to this one also, okay. So if X want to send a message here, then this router has to be in the same network, okay. At least X must feel that this router is in same network. So X will just send it to this IP address and X will treat this IP address as default gateway or gateway, okay.